we're going to learn something interesting. Rather, we're going to discuss something very interesting, which is very, very, very easy. Now, we have already discussed at the start what do we mean by a line. We know in the figure what you see is nothing but a line AB, or we call it as line P. Because when we name a line, it can be named in two different ways. By taking two distinct points on that line, like we took A and B and we named it line AB, or you call it as line BA. It's one and the same. And these are two different ways of writing the same thing, right? And otherwise, instead of taking two distinct points, we can just take a alphabet, a small letter alphabet outside the line and name it as line P. Those are the two different. And we have learned about a line that it has arrowheads on both the sides. What does that indicate? It indicates that it moves infinitely in both the direction, right? We're going to learn something more now. We learned about a line. Now we learn something called as line segment. Now what is a line segment? Right? This is a line segment. You see, does this mean that it is going to have move infinitely in both the directions like a line? No. Because does it have an arrowhead on both the sides? No. That is only with a line. This is a line segment. You see here the end points. These are called these points. Let's say if this is A and this is B, here those points are called as the end points of that segment. So when we talk about a segment, it is finite. It is finite. It starts from A, it moves up to B. That's it. So that means the line segment is always finite. And the 2 points, they are called as the end points of that segment. So when we name a segment, we name it with its end points. That means we call this as segment AB. And we write it this way, segment AB, or we write it AB and a segment above that. In a line, we put a line that is with two arrowheads on both the sides, right? That's the difference. That's a line, moves infinitely in both the direction. A line segment, it is finite. It has end points, right? One point to another point. But you call this as segment AB, or we call it as segment BA. They're one and the same. That means you call it as segment AB or segment BA, represented this way or this way. It's one and the same, right? So remember, a segment, a line segment is always finite. And line segment is always a part of a line. It's a part of a line. Line is infinite, but a segment is finite, having the end points. Was that easy? Very, very, very simple, right? Now let's learn. Now we know a line segment. In other words, we also call it as a segment. So what is length of a segment? Now that's very easy, very simple, right? Beautiful. Now this is a line. I take two distinct points on this line. That is, one is A, the other one is B. Now this entire line is called as line AB. And when I talk about this A and B, between that, what is this called as? If this is finite, isn't it? And this is called as segment AB. The entire line is line AB. But what is this? This is segment AB. That is finite. Whatever is the distance between A and B is nothing but it is called as length of segment AB. That's so simple. So this segment is AB, and the distance between the end points, that is nothing but that is called as the length of a segment. So that means here, if the distance between A and B is 8 centimeter, we can say that length of AB, that is length of segment AB, is 8 centimeter. If it is 5 centimeter, we can say that length of segment AB is 5 centimeter. Now how do we write it? When we have to say length of segment AB, it can be denoted as L, small letter L, into bracket AB. Means length of segment AB. If it is 8, we can write length of AB. That is, length of segment AB is equal to 8 centimeter. There are three different ways in which we can write this. We write length of AB. Length of AB is the same as distance between the end points. That means distance between A and B. So you write length of AB, or you write distance between A and B, or even if you write just AB, it means the same. So remember, AB means length of AB. AB means distance between A and B. That's so simple. Very easy, right? The next part which you are learning is called as congruent segment. Now that's so simple. We know segments, we know the length of a segment. Now we'll learn what do we mean by congruent segment. This is very easy. I'm taking a segment here. What is the name of the segment? AB, named by the endpoints. I take another segment here. What's the name of this segment? CD, named by the endpoints. So there are two segments. One is AB, the other one is CD. I want to check whether they are congruent. Congruent means they should coincide with each other exactly. Like we have two palms. I place it one above the other, it exactly coincides, right? That means we know that these two palms of mine, the left and the right, they are congruent. Same way, let me actually pick up the CD and place it over AB. Is it exactly coinciding? Yes, that means we know that AB and CD have the same length. That is why they coincided. Means if this is 5 centimeter, this is also 5. That's why they coincide with each other. That means they are congruent. So when are two segments said to be congruent? Very simple. If they are of equal length, if they are of the same length, that's the definition. Two segments are said to be congruent if they are of equal length. If this is 10 centimeter, this is 10 centimeter, then they will exactly coincide. And that is when we say that two segments are congruent. Was that easy? It's so simple. There's nothing great in that. Very, very, very easy. Right? How do we write it? That means if we say that if length of AB is equal to length of CD, both have equal length, then we say that, then we write that segment AB is congruent to segment CD. Segment AB congruent, the symbol of congruence, congruent to segment CD. That's how you write it. So when are two segments said to be congruent? If they are of equal length. Easy, very easy, right? The next one, this is very interesting. Midpoint of a segment. Now my dear child, we know what is a segment, we know what is the length of a segment, we know when are two segments said to be congruent. Let's learn what do we mean by midpoint of a segment. It's very simple, right? We have a segment. What's the name of the segment? AB, named by the end points. Now what I'm going to do is, I'm going to take a point, one more point here, between A and B. Between A and B. That means it is A dash, M dash B. All the 3 points are collinear. Okay, and this point is between the end points on that segment. So what I'm doing is, because of this point, we have two segments formed here, right? One is AM, the other one is MB, right? So I'm just taking it out. So what is this? This is AM. What is this? This is MB. My question to you is, are they congruent? That means, are they of the equal length? You will say, you look at it and say, yes. Not by looking, just overlap it. Does it exactly overlap? Does it exactly coincide? Yes, it does. That means you are saying that length of AM and length of MB, they are equal, isn't it? They are equal. And in such a case, we say that M is the midpoint of segment AB. So what did you learn? M is the midpoint of the segment when M lies on the segment. That means A dash M dash B, and when we have length of AM equal to length of MB. So whenever we say that M is a midpoint of a segment, that means one thing is very clear, that AM is equal to MB, and the next thing which is very clear is that it is A dash M dash B. That means A, M and B are collinear, and we know the betweenness, that is M is between A and B. That is what we understood. So we say that M is said to be the midpoint of a segment. M is said to be the midpoint of segment AB if first condition, as we saw, M is between A and B. And the second condition is AM is equal to MB. If this happens, then we say yes, M is the midpoint of AB. Now one thing, so that means very difficult question I'll ask you. Think, very difficult, think. If AB is 10 centimeter and M is the midpoint, what is AM? We'll say it's so simple. It is very easy, because this will become 5 and this will become 5. Both will be 5. Because when M is the midpoint, that means each of those equal parts will be half the length of the entire segment. Now from this, there is one more interesting fact which I want you to tell me. Think. Now this segment has a midpoint, that is M, right? That is what we have right now. My question is, can this segment have one more midpoint? Think. Because now if I say this is 10 centimeter, because of the midpoint you are saying AM is 5 and this is 5, isn't it? Right? Now can we have another M here such that AM will be equal to MB? Think. Because if I take M slightly to the left here and we have a point M here, new point M here, then this length of AM and the length of MB will not be same. This AM would be small and MB would be bigger. That means we can't say M is the midpoint. If we take this M to the right slightly, then the length of AM what we get and the length of MB what we get would not be same. This AM would be bigger and MB would be smaller. That means, what are you saying? What we mean to say is that the same thing as we are thinking, that M is the only midpoint of the segment. That means what we are saying is that every segment has one and only one midpoint. Remember that. Every line segment has one and only one midpoint. Very important. Remember this. Very, very critical. This can be asked as a true or false, right? Very important. Now let's learn about something very simple. What is that? Comparison of segment. This we know. What do you mean by comparison? We know when two segments are to be congruent, if they are equal length. Now if I ask you when is one segment smaller or greater than the other, you will say it's so simple. Suppose we have a segment that is AB and we have a segment that is CD. From the look itself right now, you'll say if you take it up and place it over here, will it exactly coincide? No. This is smaller, this is bigger, right? That means here we can say that segment AB is less than segment CD or is smaller than segment CD, or we say that segment CD is greater than segment AB. That means based on the length, we can decide whether one segment is greater than the other or not. Easy, that's so simple, right? Beautiful. Now, very important thing is properties of congruent segment. That's very easy. We know the first is reflexivity. What does that mean? Reflexivity means that every segment is congruent to itself. That means segment AB is congruent to segment AB. Segment CD is congruent to segment CD. Segment PQ is congruent to segment PQ. So every segment is congruent to itself. That is nothing but that is property of reflexivity. The next one, it is property of symmetry. What does that mean? It's very simple. If segment AB is congruent to segment PQ, it means that segment PQ is congruent to segment AB. That means first segment congruent to the second, second is congruent to the first. It's so simple. And the last and the most important property is nothing but property of transitivity. Now that's very important. What it says is segment AB is congruent to segment CD and segment CD is congruent to segment DF. Then we know that segment AB is congruent to segment EF. What it means is first segment congruent to the second, second congruent to the third, then first is congruent to the third. That is what it means. So remember the three properties for congruent segments. Easy, very easy. Now observe here. What are we seeing here? We are talking about a line. We know line extends, moves indefinitely, infinitely in both the directions. That is why we have arrowheads on both the sides. Now we call learning something called as ray. That is interesting. If you look here, do we have arrowhead on both the sides? No, we have arrowhead on one side. Here this is moving to the right, only infinitely in one direction to the right. Isn't it? And it is finite at one point. Such a figure is called as a ray. So what happens? A ray has a finite point. It starts from one point and moves infinitely in one direction, right? That point from where it starts is called as the origin of the ray, because that is from where the ray started. That is the origin of that ray. So that point is called as origin, and it moves infinitely in one direction. So in that direction, it is a lot of points there. You take any point there. Let's say I take that point as B. It starts from the origin, moves infinitely in the direction of B, and when we name this ray, when we name this ray, a ray always is named starting with its origin. So what is origin? Origin is A. So when we name this, we name it as ray AB. Very critical. We can never call it as ray BA, because whenever we name a ray, it always has to be named starting with the origin. Origin is A. So remember that. Be careful. A line AB can be called as line BA. A segment AB can be called as segment BA. But a ray AB cannot be called as ray BA. Remember that. This can be again asked as a true or false. Now when we write ray AB, we write it this way, or we can write AB and put a ray, right? Not a segment, not a line, only on one side moving, arrowhead on one side. That is ray AB. So as I said, can we call it as ray BA? No. Can we write it this way? No. Remember that. So remember, every ray has an origin and it moves infinitely in one direction, and whenever we name it, we always have the name starting with its origin. Remember that. Very, very, very critical. So now you know what is a ray. Now we learn one more interesting fact, that is nothing but, observe this very carefully. This is very interesting. Again about rays. So we have a line. What's the name of this line? It is line L. I'm taking a point here, that is A, right? So isn't this a ray? starting from one point and moving infinitely in one direction, right? So I want to name it, so I take a point B here. So what's the name of this ray? It is ray AB. Can we call it as ray BA? No, always name it starting from the origin. Okay, now look here, I start from here and move infinitely in this direction. Is this a ray? Yes. Let's name it. Let's take a point here, C. So what's the name of this ray? Ray CA? No, it's ray AC, because you always name it with starting with the origin. Now look here, there's something very interesting which you're going to learn. We have a ray AB, we have a ray AC. Do you see something? Ray AB, what is the origin? A. For ray AC, what's the origin? A. That means both the rays, they have a common origin. They have a common origin, right? So ray AB and ray AC have a common origin. Beautiful, they have a common origin. What more? If you look at this ray AB and ray AC, are they lying on the same line? Yes, they are lying on the same line. It's on the same line L. Beautiful. They are on the same line and they are in opposite direction. One is moving to the right, the other one is moving to the left. So what did you see? See the conditions. What are the conditions? Is both the rays have a common origin. They have a common origin. They lie on the same line and are moving in opposite direction. When this happens, then we say that ray AB and ray AC, such two rays, they are called as opposite rays. That means we say that ray AB and ray AC are opposite rays. So we learned the concept called as opposite rays. So I repeat, what are opposite rays? It's very simple. What are opposite rays? Two rays are said to be opposite if they have a common origin, right? What's the next condition? I said they should lie on the same line and should be moving in opposite direction. Then we say that they are nothing but they are called as opposite rays. Beautiful. Isn't that very, very, very easy? Beautiful. Now observe very carefully. I'll just give you a few examples and you have to identify whether you find opposite rays there. Observe. Look at this. You have a ray QP and a ray QR. Observe them. Ray QP, ray QR. When we talk about opposite rays, you know, they should have the same origin. They should be on the same line and in opposite direction. Observe. Ray QP, ray QR. Do they have a same origin, common origin? Yes, that is Q. But are they on the same line? No, they are not on the same line and they are not in opposite direction. That means the second condition is not satisfied. So are these two rays opposite? No. Look at the next one. Look at ray AC and ray AB. Do they have a common origin? Yes, that's A. Are they on the same line? Yes, they are on the same line and they are in opposite direction. That means the second condition is also satisfied. That means here we can say ray AB and ray AC are opposite rays. Was that easy? Let's look at the third one here. Ray LM and ray LN. Observe them. Do they have a common origin? Yes, they have a common origin L. But the second condition, are they on the same line? They are not on the same line. So is the second condition satisfied? No. That means are they opposite rays? No. That is what we understood. That means out of this three, only in the second case, we had the two rays, ray AB and ray AC. They were opposite because they had a common origin and they were lying on the same line in opposite direction. So you understood this concept of opposite rays, right? Was this easy?